Hello class, this is the second example of applying mathematical induction to divisibility tests. In this example, it's nearly identical to the first one, except the expression and the value that we're dividing by is different. So at any point, you can pause the video and give this a go yourself. If you do make an attempt for yourself, you will find that the way you've done it is it might be different, but it should generally follow the procedure that I'm about to show you. So here we go. So first we say if the expression 5n minus 1 is divisible, I'm going to take a few shortcuts in writing, is divisible by 4, then the expression 5 to the power of n minus 1 is equal to 4 times m. For any integer, we need to specify that it's definitely an integer, because if we say for any, then it won't necessarily work for every single number. For any integer, m is greater than or equal to, following the same domain, 1. Okay, so here we go. Step 1, we let n is equal to the smallest value in the domain, 1, and we test that value. So 5 to the power of 1 minus 1 equals 4m. 5 to the power of 1 is 5. Take away 1 is 4. And then this statement is definitely true. So it's true for n is equal to 1, since m can equal 1 in this instance. Step 2, for any integer, k is greater than or equal to 1, we assume this to be true when for n is equal to k. So our expression is now 5 to the power of k minus 1 is equal to 4m. And now we need to prove for n is equal to k plus 1. Substituting that into our expression here, 5 to the power of k plus 1 minus 1 is equal to 4m. So let's begin the real work here. Looking at the left hand side, we can already split this apart in case you still don't see it here. 5 to the power of k plus 1 is the same as 5 to the power of k times 5 to the power of 1. And because of index laws, those two indices should add to become this. So I'm going to write it as 5 times 5k minus 1. And just as before, we're going to rearrange our original value for n equals k. So 5k is equal to 4m plus 1. We're going to substitute that here. So it'll become 5 outside of 4m plus 1 minus 1. Expanding this, we get 20m plus 5 minus 1, which is 20m plus 4. From here, we can factor out 4 outside of 5m plus 1. And then from here, You don't have to go up here. This is just how I'm making it fit onto one page. Then from here we can say that this is of the form of the form 4m. So you can say that this is equal to 4m, which is equal to the right hand side of what we were trying to prove. So step 3 is we just finalize this. We can say another way we can say it is from step 1 and step 2, the expression 5n minus 1 is divisible by 4 for any integer n is greater than or equal to, so copying this, 1. And that is the end of that proof by mathematical induction. So I hope that gave you a slightly more slight more confidence in answering these questions yourselves. And I'll see you in the next video for the next example. Best of luck.